Article 225.36 mandates that feeder panels in separate buildings must be suitable for use as service equipment when fed from a single main switchboard and serving multiple loads within the building. This ensures the panels are equipped for safe and reliable electrical distribution. ULSE, or Underwriter's Laboratory Service Equipment, panels typically feature a bonding strap that connects the neutral bus to the ground bus. In a standard service entrance, this bonding strap is crucial for establishing a connection between neutral and ground, mitigating voltage imbalances and preventing electrical hazards. However, in a scenario where feeder panels are connected to a single main switchboard, this bonding strap can inadvertently create a parallel path for neutral current to flow back to the main switchboard. This situation is in direct violation of Article 250.32 BOM, which explicitly prohibits parallel paths for neutral current. Addressing this issue requires careful consideration. Firstly, removing the bonding strap in the feeder panels is a possible solution. Eliminating the bonding strap effectively removes the parallel path for neutral current, ensuring compliance with Article 250.32 BOM. However, it is crucial to note that removing the bonding strap may invalidate the UL listing of the panels. Therefore, this step should be approached with caution, and it is strongly recommended to consult with both the panel manufacturer and UL for guidance on the implications and proper procedures. Secondly, another approach is to omit the equipment grounding conductor, or EC, with the feeder. This forces all neutral current to flow through the neutral bus of the feeder panel and then back to the main switchboard through the feeder conductors. This method preserves the UL listing of the panels and still adheres to Article 250.32 BOM. However, it is paramount to verify that the feeder conductors are adequately sized to safely handle the anticipated neutral current load. The recommendation is to remove the bonding strap in the feeder panels, but only after consulting with both the panel manufacturer and UL. This comprehensive approach ensures compliance with all relevant electrical codes while simultaneously maintaining the safety and reliability of the electrical system. Article 250.32 BOM is quite specific. It states that the grounded conductor, typically the neutral, shall not be connected to the equipment grounding conductors and the load side of the service disconnecting means. In other words, the neutral and ground must be kept separate downstream of the main service disconnect. The reason for this rule is to prevent objectionable neutral current from flowing on the equipment grounding conductors. If neutral current were allowed to flow on the grounding conductors, it could create a shock hazard and interfere with the proper operation of sensitive electronic equipment. When dealing with electrical systems, safety is the priority. Consulting with the panel manufacturer and UL is crucial because they can provide specific guidance based on the panel's design and the applicable codes. They can also help you assess the potential risks and benefits of each solution. The electrical codes are complex and can be challenging to interpret. If you are unsure about any aspect of the code, it is always best to consult with a qualified electrical engineer or inspector. Considering the impact on the system's grounding and bonding is vital. Grounding and bonding are essential for electrical safety. They provide a path for fault current to flow back to the source, which helps to trip the overcurrent protection devices and prevent electrical shock. It's important to ensure that any changes you make to the system do not compromise its grounding and bonding. In the scenario described, the counterpoise ring around each building and the bonding of these rings together contribute to a robust grounding system. This is good practice and helps to minimize ground potential differences between buildings. However, it also means that any parallel paths for neutral current are more likely to create problems. If you decide to remove the bonding strap, be sure to properly insulate and terminate it so that it cannot accidentally come into contact with any other conductive surfaces. Also, label the panel to indicate that the bonding strap has been removed and the reason for its removal. If you decide to omit the EGC with the feeder, be sure to use a 4-wire feeder with a full-size neutral conductor. The neutral conductor must be sized to carry the maximum unbalanced load. Also, check with the local electrical inspector to see if they have any specific requirements for this type of installation. The NEC, or National Electrical Code, provides specific guidance on the sizing of neutral conductors. Table 220.61 allows for a demand factor to be applied to the neutral load calculation in some cases, but it is important to understand the requirements and limitations of this table. In general, it is always best to err on the side of caution and size the neutral conductor larger than the minimum required size. When sizing the feeder conductors, consider the voltage drop. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction and can also increase energy consumption. The NEC recommends limiting the voltage drop to 3% for feeders and 5% for branch circuits. To minimize voltage drop, use larger conductors or run shorter feeders. When working with 488 to 177 volt systems, it is important to be aware of the potential hazard. 488 to 177 volts is a high voltage system, and contact with live parts can be fatal. Only qualified personnel should work on these systems. Always use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. Follow all safety procedures and lockout/tagout procedures. Before working on any electrical equipment, always verify that it is de-energized using a voltage tester. Never assume that equipment is de-energized just because the circuit breaker is turned off. It is also important to be aware of the arc flash hazard. Arc flash is a dangerous electrical explosion that can occur when a short circuit occurs in the air. Arc flash can cause severe burns, blindness, and even death. The NEC requires an arc flash hazard analysis to be performed for all electrical equipment that is likely to be worked on while energized. The results of the arc flash hazard analysis must be used to select appropriate PPE and to establish safe work practices. Remember, working with electricity can be dangerous. Always take the necessary precautions to protect yourself and others. If you are not qualified to work on electrical equipment, hire a qualified electrician. Proper documentation is essential. Keep detailed records of all changes you make to the electrical system, including the removal of the bonding strap or the omission of the EGC. These records should include the date of the change, the reason for the change, and the names of the people who performed the work. Also, update the electrical drawings to reflect the changes. This documentation will be helpful for future troubleshooting and maintenance. It will also be important if you ever sell the building. Be sure to communicate these changes with the building owner. Proper communication is key to ensuring that everyone is aware of the changes and any potential safety implications. Training is another factor. Ensure that all personnel who work on the electrical system are properly trained and qualified. Training should include both theoretical knowledge and practical skills. Regular refresher training is also important to keep personnel up to date on the latest codes and safety practices. Another note to consider is the coordination with other systems. The electrical system is just one part of the overall building system. It is important to coordinate the electrical system with other systems such as the fire alarm system, the HVAC system, and the security system. This coordination will help to ensure that all systems work together safely and effectively. Maintenance is very important. Regularly inspect and maintain the electrical system to ensure that it is in good working order. This includes checking for loose connections, damaged wiring, and corroded components. Also, test the overcurrent protection devices to ensure that they are functioning properly. Preventive maintenance can help to prevent costly repairs and downtime. Also consider the possibility of future expansion. When designing the electrical system, it is important to consider the possibility of future expansion. The system should be designed to accommodate future loads. This may require installing larger conduits, conductors, and equipment than are currently needed. It is also important to leave room for future panels and transformers. Consider surge protection. Surge protection devices, or SPDs, can protect sensitive electronic equipment from damage caused by voltage surges. SPDs should be installed at the service entrance and at each subpanel. The type of SPD should be selected based on the expected surge environment. There are different types of SPD available, including Type 1, Type 2, and Type 3. It's important to select the appropriate type of SPD for the application. Consider harmonics. Harmonics are distortions in the electrical waveform that can be caused by nonlinear loads such as electronic ballasts and variable frequency drives, or VFDs. Harmonics can cause overheating of transformers and conductors, as well as malfunction of sensitive electronic equipment. If harmonics are a concern, consider using harmonic filters or reactors to reduce the harmonic distortion. Also, be sure to size the transformers and conductors to accommodate the harmonic current. Check the short circuit current rating of the equipment. The short circuit current rating of the equipment must be greater than the available fault current at the equipment location. If the short circuit current rating is too low, the equipment could be damaged or destroyed in the event of a short circuit. A short circuit study should be performed to determine the available fault current at each location. Also, consider energy efficiency. When designing the electrical system, consider energy efficiency. Use energy-efficient lighting, motors, and equipment. Also, consider using energy management systems to control and monitor energy consumption. Energy-efficient design can save money on energy bills and reduce the environmental impact of the building. Always follow the manufacturer's instructions. When installing and maintaining electrical equipment, always follow the manufacturer's instructions. The manufacturer's instructions provide important information about the equipment's installation, operation, and maintenance. Failure to follow the manufacturer's instructions could void the warranty and could also create a safety hazard. If you have any questions about the manufacturer's instructions, contact the manufacturer for clarification. Lastly, consider the impact of the electrical system on the environment. The electrical system can have a significant impact on the environment. Use sustainable materials and practices whenever possible. Also, recycle electrical equipment and materials when they are no longer needed. Sustainable design can help to reduce the environmental impact of the building. Furthermore, consider the coordination of overcurrent protection devices. Proper coordination of overcurrent protection devices, such as circuit breakers and fuses, is essential for ensuring the reliability and safety of the electrical system. Coordination means that the overcurrent protection devices are selected and arranged so that the device closest to the fault will trip first, minimizing the extent of the outage. A coordination study should be performed to determine the proper settings for the overcurrent protection devices. Remember to also consider the use of ground fault protection. Ground fault protection is a type of protection that detects ground faults, which are faults that occur when current flows from a live conductor to ground. Ground fault protection can help to prevent electrical shock and fire. The NEC requires ground fault protection for certain types of equipment, such as service disconnects and feeders. Also, consider the use of arc fault circuit interrupters, or SIs. SIs are circuit breakers that are designed to protect against arc faults, which are dangerous electrical arcs that can cause fires. The NEC requires SIs in certain types of circuits, such as bedroom circuits. Remember to always keep the electrical panels accessible. Electrical panels must be readily accessible for inspection, maintenance, and repair. Do not block access to the electrical panels with storage or other obstructions. Also, be sure to provide adequate lighting in front of the electrical panels. Think about the labeling requirement. The NEC has specific requirements for labeling electrical equipment. All electrical equipment must be properly labeled to identify its function and voltage. Also, the labels must be durable and legible. Accurate labeling is essential for safety and for troubleshooting. Also, remember to maintain the separation of high and low voltage wiring. High voltage and low voltage wiring must be kept separate to prevent the possibility of electrical shock. The NEC has specific requirements for the separation of high and low voltage wiring. In addition, consider the ambient temperature. The ambient temperature can affect the ampacity of conductors and the performance of electrical equipment. The NEC has tables that provide ampacity correction factors for different ambient temperatures. Be sure to apply these correction factors when sizing conductors. Remember to account for dirting factors. The NEC requires that conductors be derated under certain conditions, such as when multiple conductors are bundled together in a conduit. Derating reduces the ampacity of the conductors to prevent overheating. Be sure to apply the appropriate derating factors when sizing conductors. Think about the expansion and contraction of conduits. Conduits can expand and contract with changes in temperature. This expansion and contraction can put stress on the conduits and the equipment they are connected to. The NEC has requirements for expansion fittings to accommodate the expansion and contraction of conduits. Also consider the corrosion protection. Electrical equipment can be subject to corrosion in certain environments. The NEC has requirements for corrosion protection for electrical equipment in corrosive environments. Be sure to select equipment that is suitable for the environment. Remember to inspect the electrical system regularly. Regular inspection of the electrical system is essential for identifying potential problems before they become serious. Inspection should be performed by qualified personnel. Also, consider thermal imaging. Thermal imaging can be used to detect hot spots in electrical equipment, which can indicate loose connections or other problems. Thermal imaging can be a valuable tool for preventive maintenance. In addition, consider power quality monitoring. Power quality monitoring can be used to identify power quality problems such as voltage sags, swells, and harmonics. Power quality monitoring can help to prevent equipment malfunction and downtime. Think about using a qualified electrical contractor. When hiring an electrical contractor, be sure to use a qualified and licensed contractor. A qualified contractor will have the experience and knowledge to perform the work safely and correctly. Also, be sure to check the contractor's references and insurance. Lastly, consider getting a second opinion. If you are unsure about any aspect of the electrical system, it is always a good idea to get a second opinion from another qualified electrical engineer or contractor. A second opinion can help to ensure that you are making the best decisions for your electrical system. The NEC is updated every 3 years, so it is important to stay up to date on the latest requirements. The NEC is a complex document and it can be difficult to interpret. If you have any questions about the NEC, consult with a qualified electrical engineer or inspector. Always prioritize safety. Electrical safety should always be the top priority. Follow all safety procedures and use appropriate personal protective equipment. If you are not qualified to work on electrical equipment, hire a qualified electrician. Removing the bonding strap is generally the better option because it completely eliminates the parallel neutral path. However, it is crucial to get approval from the manufacturer because removing the bonding strap might affect the product's UL listing. The second option, removing the EGC, is okay, but it should be the last resort. The EGC is there for a reason, and that is to protect people.